Hi, I'm Courtney Nash, and I am the creator of The Void, which I will talk about momentarily, a few things about me. Yes, I was once upon a time a cognitive neuroscientist. I got my undergrad degree in Portland, but I actually went to graduate school not far from here in Champaign-Urbana at UIUC. Any UIUC grads? Woo-hoo. All I can say is, wow, Chicago is really different 25 years later. So I was almost done with my degree there. I was really fascinated by the brain and how humans learn and remember. And then this funny thing happened. It was the mid-90s and it was the internet, and I just couldn't resist. So I left grad school without the fancy parts, like, the P and the H and the D and the other stuff that I all paid for, because it was just too compelling to go off and work at some of these places that you may have heard of. That was back before AWS was like a glimmer in anyone's eyes, by the way. And that place, I lived in Seattle, but then I landed at a funny little place called O'Reilly Media. And I started out as an editor there, but I slowly worked my way into what was happening at the time was sort of the DevOps movement, if any of you are familiar with that stuff. So I ended up chairing the O'Reilly Velocity Conference for quite a few years with John Allspaw. Any John Allspaw fans in the audience? A couple? Oh, hi. Okay, cool. I'm going to introduce you to a bunch of concepts that we started really digging into at that point in time. And it's when I became fascinated with complex software systems, but in particular because of my given bent, the role that humans play in those systems. And along the way, towards the end of my tenure there, this funny little book came out. I'll talk about that in a minute too. So I worked at a couple other startups along the way, and then I landed, thankfully, during the pandemic at Verica with Casey. And I've been very fortunate to exist in a very interdisciplinary research role there, where I get to spelunk the ways that computers continue to try not to do what we tell them to do. And so I started this thing called The Void, the Verica Open Incident Database, which I promise I will talk about a bit more. But first, we're going to talk about resilience. And quite a few talks here today have used this word. And I want to talk about this word in depth. And I have a 3-act arc about resilience. The first will be about language and the way we use it and why it matters. The second will be how we measure what we think it is, because we're technologists and we like to measure everything, right? And the third will be, if I've convinced you maybe we've been wrong, what the way forward will look like. So, Act 1, resilience. This is my central thesis, okay? It's also like my favorite book from when I was a kid, and obviously one of the best movies of all time, inarguably. Yeah, so I'm going to use a bunch of words. I'm going to show you words out in the wild. These are words from books. These are words from incident reports. These are words that people have written on the internet about things that we think are resilience. Here's a few of them. I'm responsible for some of this, right? How many people here have some responsibility for the resilience of the systems at your company? How many of you have that in your title? Not many of you. Okay, all right. I believe this is becoming somewhat more synonymous with that. It's a role. It's a set of responsibilities to, in theory, right, handle the resilience, keep things running, right? This is one way that we talk about resilience, and lots of books and things have been written about that. I'm going to read you a bunch of words that people have written now in incident reports, because that's when you find out whether things really are or aren't such. So Cloudflare had a customer impacting issue. Speed testing tool was not working reliably. That's the actual title of an incident report. The next set of these are all come from incident reports. While we were working on these long-term improvements, we have put the following immediate short-term measures in place to improve our reliability. Trello. Have anybody heard of this place? They plan to apply additional layers of network throttling to help protect the network reliability when increased traffic surges occur. This is all good stuff, right? To ensure reliable operation, our DNS servers disable those BGP advertisements if they themselves cannot speak to our data centers, since this is an indication of an unhealthy network connection. Facebook. Gartner chimes in. Okay, this isn't an incident report. This is just Gartner. Cloud services are becoming more reliable, but they're not immune to outages. True story. The key to achieving reliability in the cloud is to build in redundancy and to have a clear incident response plan. I can't really necessarily disagree with that, but that's a lot of words that are all potentially saying the same thing. Redundancy, maybe robustness. These are another word that we use often. Disabling the validation would eliminate the immediate risk and give us time to slowly roll out a properly robust solution in the near future without having to worry about disrupting the whole system. GitLab. Duo is committed to providing our customers a robust, highly available service. This issue typically would be caught by integration tests that are run during the code deployment process, and this issue exposed a bug in our integration test suite. If anybody was here for the morning keynote, these are the kinds of things also that Kelly was talking about. The ways in which our systems tell us whether we want them to or not, what's really happening versus what our mental model is. Google, however, some file systems are not designed to be robust against cases where some parts of the block device presented by PD fail to initialize, while others are still usable. And OpenAI, anybody heard of them? ChatGPT. They had an incident not too long ago, and they improved the robustness and scale of their Redis cluster to reduce the likelihood of connection errors at extreme load. I hope that worked. We've made our workaround configuration more robust, as AWS has not yet provided an ETA for a fix. Performance should be back to normal. AWS. They'll come up again. Microsoft rerouted traffic to our resilient DNS capabilities and are seeing improvement in service availability. Now we're on to resilience, right? This outage was caused by a change that was part of a long-running project to increase resilience in our busiest locations. Cloudflare. We're going to hear from them again in a little bit, too. Wistia. Does anybody remember Wistia? Should a similar issue occur in the future, Wistia servers should be more resilient to it because of the changes we made today. Here we are again with our friends from Seattle. Although the AFD platform has built-in resiliency and capacity, there's another word we use a lot, we must continuously strive to improve through these lessons learned. Atlassian had a doozy a couple years back. I don't know if anybody remembers that one. We see two main avenues to increase our resiliency during an incident where AWS, there they are again, auto-scaling is blocked. Duo, one more time. We intended to determine why this unique double failover situation left a small percentage of connections in a failed state and continue to put systems and processes in place ensuring that all Duo services are resilient to failure modes of any kind. So these are what I and other folks in the space who research these things call the 3 Rs, right? Reliability, robustness, and resilience. They're words that we use often interchangeably together at different times and seemingly to mean the same thing. But I'd like to put some definitions around this, and I'd like to see if you all agree with me on these definitions or not, right? Because language is changeable, language is fungible, and meaning is only created by a shared understanding, right? Okay, here's a definition I would offer of reliability. System X does what it's designed to do every time. It is predictable and trustworthy. Yes, no? Does that meet people's understanding of the definition of something that is reliability or the state of reliability, something that is reliable? Good old Swiss Army knife. I hear the Swiss trains are really reliable too. Robustness. System X can cope with predictable challenges or perturbations. We're really familiar with this one, right, in what we do. We have lots and lots of ways of trying to build in robustness to our systems, right? Out of memory killers and autoscalers and bulkheads and, load balancers and like all good stuff, right? But the nature of robustness is that it is intended to cope with predictable or known perturbations. And I've got a quote down here from David Woods, who I'll talk about a little bit more, who's a researcher in this space. Robust control works and only works for cases where the disturbances are well modeled. Not just understood, but well modeled, okay? Any quibbles with this definition of robustness? Does anybody think I'm missing anything? See, it feels right? Okay. Different from reliability? Yes, okay. Still on the same good track here. Resilience. So the definition I'm going to work with for today of resilience is that System X can adapt to unanticipated disturbances. And this is a picture, very blurry on this ice cream picture of fireweed, which is something that's very common in my part of the world in Washington State and pops up after fires. And it's beautiful, and it's remarkably resilient, but we won't get into that so much. So here's another quote from another researcher in this space, a colleague of David Wood's. And if I could recommend this book to everyone, it's one of a small set of books, Drift into Failure. I'll have a set of references at the ends. But I want you to listen to the words that are in this quote from Sidney Dekker. Resilience is seen not as a property, but a capability to recognize the boundaries of safe operations, to steer back from them in a controlled manner, to recover from a loss of control if it occurs, and to detect and recognize the phase of operation when the margins are skipped or crossed. So any ideas about what's unique about those words I've chosen? What are they? No English literature or like language majors in them? They're verbs, they're action, they're things we do, right? And they are such that you can't just have resilience, okay? So this is where we're building to about this. So you are in the adaptive universe. This is a concept, also whether you like it or not, introduced by David Woods, the fellow that I had mentioned earlier. He's a professor and a researcher at Ohio State University. He got his start basically with 3 Mile Island. 3 Mile Island is kind of the origin story of a lot of human factors and cognitive systems engineering in the modern world, where we are dealing with these very complex systems and how they can fail. He was also very involved in the Columbia shuttle disaster reckoning and response after that. So he spent a lot of his time, and he has a paper, The Theory of Graceful Extensibility, Basic Rules that Govern Adaptive Systems. And if you came to Kelly's talk this morning, you heard some of this language there as well, right? Graceful degradation, graceful adaptability, the ability to adapt. And I want to, before I dive into some of the properties of the adaptive universe, I want to give you this diagram that for me is sort of a great visualization of that. And it comes from a researcher who David Woods sort of followed in his stead, a researcher named Jens Rasmussen. So you're here, maybe at some point. We'll talk about that a bit. But these are 3 boundaries. And this is, I don't have the paper written up here right now, but from Rasmussen. This is in 1997, okay? So right about the time that I was getting super wide-eyed about the internet and how all this works. But this is from people who were studying other things. This does not come from the internet. This does not come from software. This comes from people who studied aviation, nuclear power plants, sort of shuttle disaster types of things. And it's so evergreen. And I find this diagram to be so useful when I'm trying to think about what it means to exist in the adaptive universe. And there's 3 boundaries to this model that Rasmussen posits. One of them is the economic failure boundary. Are the lights on and running, right? Are you Twitter? It's working right now. So that might be the last shot fired at Twitter this conference. I don't know. Probably not. The other boundary is unacceptable workload, right? Like, are you having to push people so hard to exist within this adaptive universe that they start burning out, or they're sick all the time, or you just literally can't get the things done you need to get done to keep the lights on, right? And the money flowing in, or whatever it is you do. And on this side is the boundary that most of you in this room are probably the most familiar with. Rasmussen called this the acceptable performance boundary, right? And that is when things are working just fine until they're not, right? It's the cliff you fall off of, but the catch is you never know how close you are to that boundary. You think you do. We're going to talk about that a little bit more in a minute, but you don't. And at any minute in time, you exist at some operating point in between all of these boundaries, which shift and change. Those boundaries don't stay fixed, right? And you even operate in this sort of Brownian motion, if you will. Another researcher, Richard Cook, used that term, which I really like, and fans of physics. It's constantly bouncing around as it's reacting to all of these pressures that you can't entirely model or see. Okay, so this is the visual manifestation of the adaptive universe. So the adaptive universe has 2 principles. Very simple, just 2. No problem, right? resources are finite, and resources are things that we're typically quite familiar with. Sometimes you can put money in, but really when it comes down to the way we're doing things right now, it's time and people. And that will always be true. And the second thing harkens back to the keynote that Dave gave yesterday. Was it yesterday? I've lost time, which is change never stops, right? What did he say? Perfection is stagnation. Perfection is frozen in time. We're not frozen in time. The inherent nature of what we do is that there are these pressures. There are external pressures, as he described, and there are internal pressures that we create in and of ourselves, feature development and all of those things. So what he was talking about is this, the adaptive universe. And the reason we need resilience is because you are always going to be surprised in the adaptive universe. Otherwise, you could just make things reliable or make them robust, right? But you can't. So you need this notion of resilience. One thing more, the law of stretch systems is sort of a corollary of this, which is that success breeds more of those new pressures, and it's very difficult to build extra capacity, right? That goes back to either time or usually maybe the money aspect I didn't talk about as much up there. But also, even if you add more people to your team, then what are you going to do? Do more stuff. Right? It never stops. And if you're really good at that, then the folks who are further up the chain are like, that was great. Do more of that. Right? So that is always going to be happening. Which brings us to this notion, right? You can't bake in resilience. Resilience is not an ingredient. It is not a state. It is a thing that you do, that you continuously do to exist in the adaptive universe. All right. Do we all agree? Maybe that's what resilience is? Okay. I already said all that. But these are the words of David Woods. It's the set of activities and capabilities that allow you to adapt, to stretch near and beyond boundaries when you reach across them, and surprise occurs. Surprise is a fundamental characteristic of this universe. Act 2, conflict. All right. How do we think we've measured? So folks who are responsible for the resilience in your systems, are you also tasked with measuring that? Okay. How do you do that? SLOs? Okay. Anything else? Any other ways that people try to measure the resilience of their system or things that they're asked to measure? No. Metrics. Okay, so what kind of metrics do we think we might be talking about? Do we know of any other ones? Anybody heard of this one? Yes? Have people heard of mean time to resolve, MTTR? Okay. Resolve, restore, remediate. Oh, here we are with these R's again. Okay. So why am I calling this the fool's gold standard? Let's talk about where this concept came from, first of all. I think many people in our industry know of it from this. Wow, that's also really blurry on a big screen. Apparently my screen capturing juju is really bad this week. But is anybody familiar with DORA, State of DevOps report, all of this? Okay. And it's sort of a groundbreaking, industry-changing, decade-running survey from Dr. Nicole Forsgren and some of her colleagues from back at the time. It started at Puppet and it moved its way towards Google, right? And they use that as one of their inputs to their surveys and highlight it as a key metric for high-performing teams. We're going to come back to that. But where MTTR really comes from is here. Line manufacturing, right? Widget making. Things that come out in a predictable order that take a very predictable set way of making. If things break down, there's a very set amount of time it takes to fix or repair those parts, widgets, or bits, or what have you. And it takes this form. This is like the old school MTTR definition, okay? The problem is that's not the adaptive universe, right? Is that? No. And actually, this is much closer to sort of where we exist. And I don't know how many of you are old I Love Lucy fans. This is actually a reenactment of my favorite I Love Lucy episode. But the line is out of control and we are just trying to keep up, right? So I want to give some more words in our own words. These are things that people have said or written about MTTR and whether or not we think this could be a good indicator of the resilience of our systems, all right? Bear with me, it's a lot of words, but we'll go really quick, okay? MTTR it measures how quickly a team can restore service when a failure impacts customers, allows enterprise-level organizations to track the reliability and security of technical environments, allows teams to set standards for reliability, accelerate velocities between sprints, and increase the overall quality of the product before it's delivered to the end user. It captures the severity of the impact, shows how efficiently software engineering teams are fixing the problems. Specifies the severity of the impact of the incident. Offers a look into the stability of your software as well as the agility of your team in the face of a challenge. Encourages engineers to build more robust systems, is one measure of the stability of an organization's continuous development process, helps teams improve their system's resilience, evaluates the efficiency and effectiveness of a system or service, measures the reliability and stability of the software that is delivered, helps track reliability, helps teams to improve their processes and reduce downtime, assesses how resilient the software is during changes in runtime, helps track the performance of both the dev and ops sides of the house, can be a great proxy for how well your team monitors issues and then prioritizes solving them. Well, I'm almost there. Low MTTR indicates that any failures will have a reduced business impact, serves as a direct customer indicator of customer satisfaction, and directly impacts system reliability, customer satisfaction, and operational efficiency. Whew. That's a lot, y'all. Like, all good, but who doesn't want any of those things? Like, nobody. Those all sound amazing, right? But a single number can't possibly give us this, right? It can't tell us all of these things. It's like the ShamWow of engineering metrics. Thanks, I'm really glad about that one. It's going to come back. And the horrible truth that I'm about to reveal to you is it doesn't actually measure any of those things. But that means it's time for statistics. You can run for the door now if you want. So now we get to the void, the Verica Open Incident Database. It's a database of incident reports, public incident reports. Has anyone here ever written an incident report for their company? Okay, have you published it online? Anybody? Yeah, you have? Yay, thank you. So if it has been published online, I'm trying to go grab them all. Right now I have over about 10,000, which is probably a drop in a very large bucket or the tip of an iceberg, or pick your metaphor. But I believe that collecting this information is incredibly valuable to us as an industry, much the same way that the airline industry started sharing its own incidents amongst pilots and air traffic controllers and other people in the 90s. I think it's incumbent on us to do this and to share with each other and to do so as willingly and as transparently as we can. And that's really what the void is about. It looks like this. It's just like a cute little website. But behind it is a database held together with duct tape and string, as they all are. So what's in there? 10,000 public or so incident reports from, it's like more like 600, not 800. So ChatGPT was definitely wrong. From 2008-ish up until now, it's got social media posts, status pages, blog posts, conference talks, news articles, tweets, in-depth public postmortems and things like that. I'm not going to get into why I have all of this right now because I don't have that much time. But I also collect a bunch of metadata on that, the organization, the date, type of report, is it a status page, is it whatever? If they talk about, was it Kubernetes, DNS, and then a bunch of other things, okay? But for now, we're gonna focus on duration because that's what really is the underpinning of this time to remediate, time to repair metric that is so pervasive in our industry. And about more than half now, almost 75% of the reports in the void have some form of duration. So let's talk about duration. I call this gray data. It's sort of like gray water, right? And there's a number of issues with it. It's super high in the variability, but very low in fidelity in terms of the information you get within it, right? It's super fuzzy on both ends. Like, who decides when an incident starts and when it stops? And are we consistent in what that means, right? Sometimes automated, sometimes not, sometimes updated, sometimes not. It's a lagging indicator of what happened in your system, and it's ultimately subjective. And then when you average all those gray inputs together, you get that. And then we're going to take the mean of that to mean something. So let's talk about what that word mean implies in this context, right? So in the statistics world, a mean means a normal distribution. Has everybody seen one of these before? Bell curve, it's Butte, right? And that's your mean, right in the middle, right? It's the central tendency of that distribution of data. And the way you get this distribution is you take all the incidences of data, this point, data, that point, that. And what it means is a majority of your things are in whatever your data look like, right? Height, weight, whatever that might look like. We have lots of normal distributions in the world. Your incident data are definitely not normally distributed, all right? So this is histograms from actual incident report data from the wild, from the void. So what we do is we take the count, bin it by hour. Okay? We're just going to say, is it an hour? Is it 2 hours? Whatever the time, the duration of that incident is according to that organization. And then we just add those up. Standard histogram. We're kind of familiar with histograms in this world, mostly. Cool. This is what incident data look like. Does that look like a normally distributed curve to any of you? No. Does that look like what you think your incident data look like? Have you ever even looked at them? Maybe not in this way, okay? So the catch with a skewed distribution like this is that the mean is meaningless. It cannot tell you useful, much less predictive or helpful things about those underlying data. It's going to lie to you. It's not nice. It's going to be like way over here. But what about the median, Courtney? Well, yeah, in some distributions that are skewed, you can take the median, but yours are so skewed that even that becomes problematic. So when I looked at these data, I was like, sweet, we're done. And people are like, no, you can't take this away from me. It's got to mean something, right? I was like, statistically speaking, it's garbage, but we're stuck with it. Like we want it. It seems so good. It seems like it makes sense. And so a couple of years ago, an engineer, an SRE, actually from Google, it's not an SRE anymore, did a really cool experiment. There's no Riley report on it. I may have failed to put that in my references section, but I'll add it. And we sought to replicate his results. Also not something that happens in our industry very often, right? We don't get to take data and do the same thing with it. So what we did was we created a new product, TT Reduce. It's super cool, just out of the box. It reduces the incident duration of your incidents by 10%. Poof, like ShamWow. All right, so this is an experiment, right? Lots of other people have been talking about experiments at this conference, which I think is super cool. Kelly talked a lot about experimenting. We did Monte Carlo experiments, but if you're not familiar with Monte Carlo experiments, you could think of this as just a fancy A/B test, right? We took real incident data from lots of these companies, and we just separated them into two groups. Group A, Group B, right? Real data, though, okay? And then we applied MTT reduce ShamWow to this set, 10% faster. And then we ran hundreds of thousands of simulations, comparing the mean of this population to the mean of this population, right? Because in theory, what matters? If you have something like MTTR, you want to say, we got better. Right? We did X, we got better. We did Y, things got worse. But that's fundamentally what we expect these metrics to help us be able to do, okay? So then once you do that, you subtract the mean from this population from the mean from this population. So if things did in fact get better, if our fancy new product worked, then you'll actually see a curve, or you'll see a percentage improvement, right? The difference between those things will actually be positive, because this number should be higher than that number, okay? Are you with me? This is kind of a hard one to explain. So these are what the results look like. Every one of those colored curves is one of the companies from the void, 10 or so that we did this with. And so what should happen is, if you have a 10% improvement, then between the two populations, the peak of your curve should be right here, right? The 10%. But what about all this stuff over here? So 30% of the time or something, it got worse. ShamWow my ass. And then over here, like a whole chunk of the time, you're fooled into thinking you did better than you did. Well, that's also not very good. And everyone always asks me, what's about this? And I'm like, that's Cloudflare. And I can explain that to you afterwards if you really want. The TLDR is you don't want as many incidents as Cloudflare has, because that actually almost gives you enough fidelity in your data. Okay, does this make sense? What this ultimately is telling you is that there's too much noise in your duration data to be useful or valuable. Okay, so I want to just talk a little bit about this other concept that John Oswald uses for these kinds of data as shallow data. They're making comparisons between things that you can't compare using a number that doesn't accurately reflect those things, right? It's kind of, like my mom used to say when I was a kid, comparing apples to Volkswagens. Or chess matches of the same duration between a chess master and two kids. Or two movies. God, I had all my examples in here and now they're gone. But like Thor the Dark World, which was like really bad. And like some other movie that was the same length as Thor the Dark World, but like won an award. So on and so forth. You get my point. We're trying to compare things with one number. And there's so much more information underneath that we don't get from that one number. Right? All right. Act 3, resolution. If not that, then what? Because that doesn't tell us about the resilience of our systems. What do we do? Right? And I get asked this question every single time. And the answer is complicated. Your systems are socio-technical systems. How many times have we heard that term now over the last 3 days? Like a lot of times, right? For a reason. You are people interacting with computers and automation and ChatGPT and building something that needs to be resilient, that needs to adapt and change over time. But our metrics don't always show that, right? So we need to collect socio-technical metrics. This is sometimes harder than just taking what your system will spit out and give you. But I want to give you some examples of what those might look like. You could choose to use some of these, you could choose not. One of my favorite ones is cost of coordination. This comes from the dissertation work of a researcher, Laura McGuire. And she also studied with David Woods at Ohio University. And she really looked into what happens when you have an incident? What happens when your systems fail to adapt? When they aren't as resilient as what you want? And what does the impact on that socio-technical system look like? These are things like the number of people involved hands-on in the incident, across how many unique teams, using what tools, in how many chat channels, were there multiple incidents happening at the same time that these people had to deal with? Did it get so bad that you had to get PR involved? These are the kinds of things that tell you a lot more about what's happening in your socio-technical systems. And they tell you about whether you need or don't need as much adaptive capacity, potentially. Other things that people are starting to track are like the participation around this kind of information. How many people are reading your write-ups? Does anybody feel like you write your incident reports and no one reads them? Sorry, it's unfortunately true. I read them. If you send them, I'll read them. The number of people voluntarily attending post-incident review meetings. Those are pretty interesting ones. I like these in particular. The number of links to your incident report write-ups from code comments, and commit messages, architecture diagrams, onboarding and training, other write-ups. Are you finding patterns, perhaps, across your incidents? Well, that's going to give you a lot more information, right? Near misses is another really fertile area. I'm not saying go try to count all your near misses. You'll hate me. But they tell you a lot about sources of adaptive capacity, where knowledge gaps are, assumptions you have, all of these things that you might get out of incident reports without the terror of an actual incident. So that's the, engineers like, something looks really weird over here, Jane. You want to come look at this? And like, oh shit. And then you fix it. Go look at that. Like, that's so important and so valuable. And the other thing I didn't have a lot of room for, which is actually honestly a whole other talk, is SLOs and SLIs and these other kinds of measures that are starting to gain a lot of traction, I think, in adoption. But I think those in isolation are not enough. So I would argue that those plus these things are what's going to give you what you need. And then in response to this, people are like, that's crazy. I can't do all that. And my answer is, yes, you can. You can. Because David Lee and Randy Horowitz, who work in the Office of the CIO at IBM, a 12,000 person organization, are doing this. They're tracking these kinds of metrics, and they're looking at how they change over time, and they're looking at the engagement and the learning that's coming from these kinds of initiatives. So this is a slide. I have 2 slides from David's talk that he gave at the Learning from Incidents conference back in February in Denver. The main thing of this is they've done a bunch of different things around how they handle incident analysis. They've made sort of different sizes of them, t-shirt sizes. This is kind of like their process. You can go back and look at this afterwards. What I think is really fascinating is this slide. So they started in January of last year. They are now tracking that they're getting 85 to 100 participants attending every monthly incident review meeting. 270 people attending more than one. Unique views of the meeting recordings. Like, this is all stuff we know how to do. We're like on the internet and stuff. Like, we know how to track clicks and see what people are doing. Unique views of the reports, feedback from the meetings, and then they're actually seeing these things that come out of it. They're doing practice drills for collaboration during Slack outages, because that bit them pretty hard once. They actually had a major project to consolidate some IT inventory because that came out some of this. And the executives were like super on board with it because of this. Leaders asking for incidents to be included in architecture, design, planning, all of those things, and just how they're scaling this over time. And so if you leave this not with just one thing, it's that resilience requires humans. It is something we do, and we do it together. This is my last choosing meme. Does anybody know the movie? Do you know which year it was set in? 2022. We've passed Soylent Green hell. So that is, I think I've run over time. I apologize. But this is the set of references that I have if you're interested in, falling down the rabbit hole with me or nerding out. Lots of detail on this kind of stuff is in the report, in case you mentioned, that I produce every year. You can go to the Void at that URL. You can get that. You can get a hold of me. And thank you all for joining me today.